Welcome to the Blue Shack. My name's Joe, and today I'm going to be working on another project. Let's get started. Today I'm going to be making a ring mandrel. This is an example of a smaller size mandrel that I've made previously. When I'm making a ring, I can finish the entire ring off of the piece of stock that I'm using. But to be able to finish the backside and polish and everything else, I need something that runs true. So what I've come up with is using a number 3 Morse taper with threads on one end, threads that typically would fit a drill chuck. But what I do is take a piece of aluminum and carve it down and tap it out so that it threads on there. And once I put this in my lathe and carve it to my lathe specifically, it runs true to my lathe. So if you want something that runs true to your lathe, this is a way to do it. There might be other methods and other styles of ring mandrels out there that work better. I don't know. And I also want to start off by saying that I am in no way a professional at machining. In fact, metal lathe work is about the only metal work that I really do. Okay, that being said, I'm starting off with an approximately 3-inch chunk of aluminum. This is a 1 1/8 inch diameter. And I'm going to go ahead and get it chucked up and we'll get started. All right, I'm going to feed that in there, not quite halfway. And get that chuck tightened up. All right, so get these calipers out of the way and get started here. I'm going to start by facing off the face of it. I like using a round tool, a carbide tool head. I like the way it finishes. If it was something more robust, like I'm used to working with 304 stainless or titanium, for stuff like that I use a pointed single point of contact tool. But for aluminum, it's really soft and easy to carve. And this makes a nice finish with just one pass or 2, depending on how much I need to take off. All right, I'm going to start by getting that carriage close. And everything's very close. I'm just going to go ahead and power this on. I'm going to touch it off. And as soon as I touch it, and it changes just a little bit, I'm going to zero out my VRO. I start by taking a 25 valve depth of cut on the carriage. Give it just a little bit of WD-40 as leading for aluminum. And I'm going to engage the power cross feed and let it do its thing. And I'll stand by with a chip brush. Sorry for the noise. This is an old lathe with a lot of belts and gears, pulleys, so it rattles a bit. Okay, let that get down to the center. And then I'm going to put it in reverse and let it power feed back out as well. Give it just a little more. Look like that outside edge it wasn't touching all the way. So I'm going to dial that in just down to 30 thou. Down to the center. And reverse it back out. Shut that off for a minute, quiet it down a little, and brush off these chips. Now, we're going to make sure the outside edge is concentric. So I move this tool over so that I'm about here on the bar, on the rod I should say. I'm going to turn this on, and then I'm going to push in the tool so that I'm making sure that it digs in all the way around. If it's not too much out of line. If it's way out of line, I'm going to have to take 2, possibly 3 passes. But typically, I found this chuck is pretty good at getting stuff centered. So we'll see. Start driving that in a little bit. Okay, it's just barely touched, and I can see that it is off a bit. And if it was anything harder, I would probably do 2 passes, but aluminum is so soft, I'm driving in just a tad more, and it will be fine to do 1 pass, one in and one back out again. That I go down is pretty arbitrary. I could actually finish any of this off with once it's on the Morse taper. But I do want to be able to knurl a bit of this. You don't have to, but it makes it look a little bit nicer and the pliers grab a little better. Okay, that's getting to be just about far enough. So I'm going to reach over here and put it in reverse and let that power back out again and then do a little finishing pass on it. You can see that, I don't know if you can see it or not, I can see it's getting a little bit smoother. It's smoother over here than it is here. Just taking that little bit of extra off. Shut this off. All right. Now, the next thing I do is knurl that, and you don't have to. I just like to. Like I said, I like to put a nice rough knurl on it so that the pliers can grab it, or I can grab it by hand easier. But this being aluminum, what I don't want is my knurler to get gunked up with shavings. So I'm going to wipe that down good. Okay. All right. Grab my knurler, which I have some pretty rough ones on there. And I know I already have this set at 90 degrees or perpendicular to my stock. I'm going to get it set on there a little bit and turn the lathe on. And I'll drive that on in. Pretty decent amount of pressure. Knock that knurl off. Okay, get rid of this. And the next thing I'm going to do is deburr and chamfer this edge just a little bit. I'm going to take my metal file here, turn this back on, and I just give it a few licks, about a dozen licks or so. Okay, I'll wipe that down again. Clear some of these chips off my ways. Okay, that edge looks beautiful. All right, so now I'm going to make sure my power feed is disengaged. Move my carriage down here so I'm making sure it's clear of the chuck when it turns. And then I am going to use a 1/2 inch high-speed steel center drill. Get that chucked up in my drill chuck on my tailstock. Slide it on down in here. Getting fairly close. And I'm going to go with the same speed. Now, I know with aluminum you can run it a bit faster, but I work pretty slow. I work pretty slow at everything I do. I don't move fast. I have this at about, I think it's 77 RPM, and that's just where I'm going to keep it for pretty much this whole project with aluminum. At titanium, I run like really slow, 30 RPM for most things. Okay, turn this on. All right, back this off. Get rid of this drill. Clean it off good. Okay, now I'm going to be using a cobalt drill. It's 29/64 is the right size for a 1/2 inch tap 20 TPI. Get that nice and centered and tightened up there. Make sure it's centered. Okay, and then what I do is I get to the 1/2 inch mark on my tailstock, just shy of the 1/2 inch mark. Then I push the tailstock in so that the widest part of the drill is flush with the face of my stock there. Oops, a little too far. Oh, wow, there we go. Okay, and then I'm going to tighten down that tailstock, back it out a little bit, and I'm going to be, I know that the Morse taper, the threaded side is 5/8 of an inch deep, but I'm going to be going a 16th past that. So what is that, 11/16? Just to give myself a little bit of wiggle room when I tap it. Okay, here we go. Slide this out of the way a little bit. Whew, it is cold in here this morning. All right, clean that off. And I'm going to clean the burrs out of the inside of that. I got my reamer. Oh, I'm going to disengage the gearing on my lathe so that my chuck spins free at this point. And I'm just going to turn that by hand, give myself a little bit of a camfer inside there, take the burrs off. Okay. Now, the next thing to do is to tap it. I'm going to start off with I'm lost for words, a tapered tap to start with. I'm going to chuck that up in my tailstock, because everything, for this to work, this mandrel to work, everything needs to be precise. I need it exactly perpendicular to my stock there. And what I do is I'm going to be turning this by hand. I'm going to just push that in ever so slightly until it stops. Now, aluminum is so soft that it can have the tendency, especially if you don't have a really good tap, is just spinning and tearing out the threads while it's making threads. It can be a real mess. So make sure you have a really good tap, high-speed steel. And then what I do is I am going to place quite a bit of pressure with my hand on the tailstock. I'm just going to keep shoving it forward. And then I'm making sure that I can see the threads of the tap actually getting sucked in that hole there as I'm turning it. So here we go. And you can see that it is moving. Well, I can see that it's moving in. Hopefully, maybe you can too. And I can also see the chips inside there as it's cutting. And eventually, this being high-speed steel does not, the chuck doesn't grab it very well. It's so hard. So it's going to start, the tap is going to start spinning in the chuck at some point. I'm going to keep it going as long as I can, back it off a little bit every once in a while. But once it reaches enough friction, there it's starting to slip a little. I'll probably get like another quarter turn on it before it really spins. And it's still going. Oh, there we go. Okay, now that it's slipping, I'll loosen that chuck. And let's leave that tap in there and slide the tailstock back. Okay, grab my tap handle. And okay, that's bottomed out. So now I'm going to apply just a there we go. I'm going to apply a little bit of back pressure that way with the tap and spin it on out. There, we'll see. Let's see when I put the Morse taper on it. Okay, now I'm going to run this backwards and let the threads remove some of those chips. There we go. Most of them. Okay. I forgot to put a little bit of WD-40 on that tap too. I should have done that before I got started. So when I take the bottoming tap, which has threads that go all cut, thread cutters that go all the way to almost to the tip of the tap, so it'll bottom out in the hole. I'm going to go ahead and give that a little bit of lubrication there, and I'm going to start this by hand, being very careful not to cross thread it. Okay, I'm going to make sure this spins freely. I mean, I'm almost putting almost no pressure on this tap handle, and it should spin pretty free until I get down to where the taper started on the other tap. There we go. Okay, I'm just going to complete the tap. Okay, clear these chips. Before I get too carried away, I'm going to clean up that edge just one more time with the reamer very, very, very lightly. Okay. And see how it feels all nice and smooth. I'm going to go ahead and put the Morse taper in and make sure it looks concentric or fairly. Okay. Yeah, that's looking good. Okay. That's what I wanted. Now it's about lunchtime here, so I'm going to take a break, go get some lunch and warm up, and I will be back with you in a minute. And just like that, I'm back from lunch. I eat really fast. All right, let's get on with this. Ooh, it's still cold today. Here in southwestern Oregon, it's a whopping 40 degrees out this morning. Well, afternoon. Okay, ready to pull this off the chuck. Make sure everything's off and I'm safe. Put this board down there to cushion in case I drop that chuck. Okay, I'm going to set this aside. Actually, just remembered, before I pull the chuck, I've got some more work to do. The rest of turning this is going to be done with the Morse taper. But since I already have the chuck on there, the next thing I'm going to do is chuck up a bolt that I'm going to use as the means to tighten the mandrel. And what I need to do is make a 60-degree taper. I use for this size of mandrel, I'm using an M8 by 1.2 thread pitch. I'm sorry, a 1.25 thread pitch. And this is a socket head cap screw, 30 millimeters long. And it seems to work pretty well. So I'm going to use another one for this project. Pretty close. Okay, got to leave myself enough room to get the tool in there. Okay, so I'm using for a tool, again, carbide cutter, kind of a diamond shaped. And so I need to set my compound for 60 degrees. I'm going to be working very close to the chuck though, so I'm going to pay close attention to that. Make sure I don't hit it. And this is a stainless steel bolt. For this, I'm going to be using some Tap Magic cutting fluid. Turn it on, and here we go. Go in 20 cal on the cross slide. Basically, I just need to taper it clear down to where the threads start. That pass got us there, all the way down to the threads, so I'm just going to slowly back it off and make this my finishing pass. That's still engaged, so I'm going to shut off the power before I do this, just in case I accidentally hit that switch for some reason. Okay. There is what we're looking for. 60-degree angle, right on down to the threads. And this will come into play later. So we're just going to set that aside. And we'll go to the next step.